Okay, so the next chapter that we are venturing into is the chapter on area. That is chapter 11. I think there's 2 full chapters left that we have to cover, and then we'll start on the Algebra 2 material for marking period 4. So today we're going to cover 2 sections, 11.1 and 11.2. We're going to talk about rectangles, squares, parallelograms, and triangles. None of these really should be new to you. This is all stuff that should have been covered in middle school, but we're going to just review it now. So area of a rectangle is your B times H. B stands for base, H stands for height. Area of square could still be base times height. Sometimes, though, the textbook will refer to it as S squared just because all the sides are the same, so they just refer to it like that, but you can certainly use base times height. Area of a parallelogram is also base times height. Another reason why the 3 of them, I'm lumping them together, and the triangle is 1/2 base times height. So there's certain questions that you're going to get where you have more than one figure sort of sealed together, making a more solid shape with multiple figures put together. And so the idea of it is you basically want to break it apart, but the total area is the sum of all the individual pieces put together. So if you have 2 figures, so you've got this shape put together with the other shape, okay, then the area would then be equal to basically the 2 of them individually figured out, and then you would add them up, and that would get you the total area for the figure. So a lot of questions you're going to be asked about total area. So we use something called the divide and conquer approach for these. And basically you're cutting the figure up and you're breaking it into more manageable pieces. So this is the original figure that you start with. Now, there is not one way to cut this figure. This is one way that I cut it myself, but you can certainly cut it horizontally, vertically, whatever way you choose to do it. But your numbers should be reflective of that. So if I chose to cut it vertically. So I basically took each and every sort of corner, if you want to think of it like that, and just drew it down. So corner, 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 and I made all 4 different rectangles, basically. Me personally, I like to stick with the rectangles just because I do think it is a little bit easier. And then what you're going to do is use the postulate from above that says, well, the total area would then be equal to the sum of the individual areas put together. So you have 4 figures going on here. Figure 1, figure 2, figure 3, and figure 4. And you have to figure out what the individual dimensions of each one is. So figure 1 is a 2x6. Figure 2 is a 5x8. Figure 3 is a 2x3. And figure 4 is a 3x8. And rectangles are base times height, so you multiply them together and add them up. And this chapter, everything is about area, which means every single one of your questions should have something along the lines of units squared. If it's centimeters, just make sure that you are using centimeters. If it's meters, make sure that you're using meters as well. But again, make sure every single answer, no matter what, just to be safe, is just make sure you have units on there. So you're not just going to get super basic types of questions. Obviously, they're going to use a lot of information from prior sections. So one example would be something like example number 2, sorry. So example number 2, we've got that figure and it says find the area. So we know it's not a rectangle, we know it's not a square, which means based on this section, and we obviously know it's not a triangle, it's a parallelogram. Okay, so if we know that it's a parallelogram, in order to find the area, we know that the area is equal to the base times height. Well, so far we know the base is 14. That's what it's sitting on. But we have to figure out what the height is. So that is where this extra number of 60 comes in. So what you could do is drop yourself an altitude, which then creates a 30, 60, 90 triangle. So I'm going to come over here. Our hypotenuse is equal to 6. So if you set up your chart for a 30, 60, 90, if the 90 is 6, we know that the 30 is then half of that, which is 3. And then the 60 would be 3 radical 3. So according to this figure, we know that the height is 3 radical 3. So we have 14 times 3 radical 3. And you will leave all of your answers in simplest radical form, as well as making sure that you have your units being squared. So again, no decimals will be given unless the question specifically asks you to round to it. So everything should be in simplest radical form, and everything needs to have units on it. All right, you might be also asked to get the area of a trapezoid. Well, we haven't officially gone over the formula for area of a trapezoid. There is a formula, so for right now, you're going to do the divide and conquer. You're going to break it up into more manageable pieces. So this first figure right here, we have a trapezoid WXYZ. So we don't know a trapezoid, but I do know what a triangle, two triangles, and a rectangle are. So that's what I'm going to do. Break it into two triangles on the side. It's not isosceles because the 13 and the 15 are not the same. But given that it is a trapezoid and it's the same trapezoid, you can make sure that the height is consistent anywhere on that figure itself. So that will stay the same. And then you basically have a Pythagorean theorem situation on both sides. So x squared plus 12 squared equals 13 squared. So you get 5 on the left, and then 9 squared, or sorry, say y squared plus 12 squared equals 15 squared, and then you would get 9 on the right. So two triangles, you have 1/2 base times height. 18 by 12, that's your base and your height being multiplied together. And then again, another triangle on the right, 1/2 base times height, giving you a total area of 300 units squared for that one. All right, number 4. So we've got, so we have the area of a square is given to us. So we're sort of think backwards a little bit, is 64 meters squared. MNOP is formed by forming the midpoints of the sides. So honestly, it doesn't really matter necessarily how you break it down, but here's M, here's N, here's O, and here's P, and it's formed by the midpoints. So we know they're going to be cut in half. Okay, and we know that they're all going to be the same because it is a square. So, given that the area is equal to 64, we know each side is 8. When you split each of those sides again in half, you end up with your 4, 4 all the way around. And the question then is asking for what is the area and the perimeter. There are two questions here, area and perimeter. So perimeter is the total distance around, and then area, we have to figure out what the dimensions are. Because whether it's a square or whether it's a parallelogram, either way, we need the base and we need the height. So you have a square to start off with, which means you also know you have right angles. So you're going to use, you can either do Pythagorean theorem or you can use 45, 45, 90. Either way, you end up with 4 radical 2 for each of these side lengths. Doesn't matter which way you chose to do it. So if you have 4 radical 2s, then that gets you a perimeter of 16 radical 2, and we're with meters. So make sure the units are the same. And then if we are finding the area of the inside figure, then you're going to do base times height, and you have 4 radical 2 times 4 radical 2. 4 times 4 is 16. Radical 2 is radical 4. And that's 16 times 2, which gets you 32 meters squared. All right, number 5. So we have this, let's see which one. We started, there's a little bit more going on here then. All right, so we have find the measure of angle A in parallelogram AX, Y, and Z. And then we got to find AX. Okay, so there's multiple things that we're looking for here. So first things first, we have 2 dotted lines. So you have to be careful about that and make sure that you're only sort of looking at one at a time. You know it's a parallelogram, which means you know that the opposite angles are congruent to each other. So, and in addition, opposite angles, we also have, think of it like this. You know that ZY, you know ZY is parallel to this guy. So if that's a right angle, we know this is going to be a right angle. Okay. Given the fact that you have alternate interior angles. My gather is you probably needed to be given the 30 here, so that's my guess, because something's definitely missing, and I know I've drawn more on here than needed. So we've got 30. We know this guy is equal to 30, which means finish the triangle, you've got 60. Finish this triangle, you've got 60. Finish this right angle, you've got 30. Finish that straight line, and then this doesn't make a right triangle over here, but just leave that for right now. So we're looking for angle A. So I have a feeling you were given Y was 30, and so then you had to make the connection that angle A is opposite it, so it needs to be equal to the same value. And then in regards to figuring out what AX is, we're going to focus just on this triangle right here. Well, it's a right triangle, so you either have the option actually, you don't have the option because 8 is the whole entire thing. You have to use 30, 60, 90 to do that. So if the 30 is equal to 6, then you know that the 90 is going to be double 6. So 6 times 2 is where we end up with the 12. All right, final example here before you get to your homework. So we've got a more involved picture. A lot of times on standardized tests, you see these questions that ask you to find the area of the shaded region. So we have a bigger figure here. You have a small little piece that gives off the shape of a triangle, but it doesn't have a necessary base or a height, so you've got to figure out the missing pieces. The whole idea of a shaded region type of problem is you find the area of the entire thing, and then you basically take away the area of the unshaded part. And then whatever remains is going to be the area of the shaded region, and that's what we're ultimately looking for. So divide and conquer again. You find the area of the whole thing, so it's a triangle. So your base is 18, your height is 13, so that's where you get the 117. And then individually, this is 6, which means this is 6. This is 5, which means this is 5. And you've got two triangles and a rectangle going on here. So 1/2 base times height gets you 24 for the first triangle. The second triangle is 1/2 5 and 12, which gets you 30. And the rectangle is 5 times 6, which is 30 put together. Add those three together. So 30, 30, and 24 gets you 84, and then take 84 away from 117, and you end up with 33 meters squared. Again, make sure you're using units on every single problem in terms of meters squared, whatever is squared for the area notation. All right, so on the bottom of this note sheet, and you could either print it out from Schoology. I would recommend taking it yourself, though. It's always beneficial to write stuff down. It helps you learn it more. But both of these bits of information, or both of these homework assignments, have those 5 problems for me for tomorrow. And make sure you take a picture and email me, not Schoology message,